yeah, make sure to watch the Netflix series about Arbiverse. It's really interesting, more interesting than you think. And yeah, so it's not working, so I'm going to make a joke in the meantime. So it's working, okay, good. So I'm still going with the joke. So in Bangkok, you know, like that there is like, I don't know, tuk-tuks, you can have the, I don't know, cab, you can take the subway, and there is like multiple ways, and sometimes you can just walk. So we have the same situation in cryptography. There is like TEs, MPCs, FHEs, like ZKs, and they're not necessarily the best answer for everything. There is no like number 42, like the ultimate answer to all of your problems in your life. And, but like there are a lot of people who say that like my solution will solve everything, which is like simply not true. So there is like some kind of trade-offs. I call it like UPS trade-offs. So like the use case, performance, and security. So for the very same reason that you sometimes take a motorcycle, it's faster, it's more efficient, but it has like less security. But sometimes if you want to go to like a wedding, you don't take the motorcycle. You don't need that, like you need more security. And with the same logic in cryptography, if you want to build like something that is very fast or like more efficient, you can use like things like T, but obviously it doesn't have the security. And like there is some like middle grounds with MPC, and if you want to do like very fancy stuff like I don't know, going to the wedding, if like confidential AI stuff, you can use like FHE. And with the same logic, like sometimes when you want to go like I don't know, like really fast somewhere in the middle of the city or like very far, you combine different modes of transportation. And we have the same concept, I call it multimodal cryptography. So sometimes if you really want to build like a very, very secure system, you combine TEs and MPCs and ZK together. It's crazy, but you need that for going really far. And if you really want to do like optimize it in a sense that is faster, you can still use ZK and MPC and T to optimize it and make it faster. So like anyways, like that was before starting, like if you really want to build something today, right now, you can just start with the QR code. It just directly guide you to our docs, which is specifically for Stylus. And I'm a big believer in blind following. So if you just blindly follow the instructions there, you can actually have an auction like in like 30 minutes. And yeah, so I call like what we are building dynamic confidentiality. We don't use the term privacy because just like we don't want to be seen as like something like Tornado Cash. We can see like, I don't know, we can build much more stuff with confidentiality, and it's about the systems, not necessarily about data privacy and users or like values. It's basically, that's like the reason behind the name confidentiality. The reason that we call it composable is that we don't really want to build like an isolated chain somewhere in the, I don't know, corner of the crypto ecosystem. We want to build like applications with actual users and developers. So we are happy that we are working with like Arbitrum and Stylus, that there are like a lot of great developers and like users, but you can actually do the same thing with like all of the other ecosystems and build there to have like access to liquidity and like other developers to build with you. And the reason behind dynamic or like dynamicity is basically the fact that we have a network that like hopefully one day we can have like the optimized cryptography solution, confidentiality solution, either like the most like fastest performant one or like the most secure one or like the, I don't know, something that in the middle for each of the applications. So if you want to do something like an auction, which is really fast, we have a solution for you. But if you want to do like confidential AI, we have like another solution. And this is like our vision right now. We are mostly focused on things that are really fast and like more secure enough. And yeah, let's talk about the applications. There are a lot of applications, but today I want to talk about like some stuff that are like newer to me, not necessarily things that you've heard. So my favorite one is confidential auctions, and it's my favorite for the reason that normally when you talk about privacy or confidentiality is always like something that is like a luxury add-on that like you should really care about the society or something, and then like it's not really necessary. But with auctions, it's like something that you can have like a more performant market. You can have like better end prices for the end users. You can have like more competitive markets. And there's a lot of like academic or in papers about that. Like if you really want to follow that, you can read like, I don't know, Tarun Chitra's paper about this. But basically, if you have, for many reasons, like I'll just name some of the reasons, so that you need confidentiality. First of all, like if you want to have like an open price, like first price open auction, there is a problem that like they call it in TradFi, the bid from chandelier, because the guy who is running the auction, they just make up something, and they call it like, there's like a really good paper from A6Z, like shield-proof auctions. So like the shilling technique is a bad thing for the market. If you want to make it like a fair market, you want to prevent shilling. And there's also a lot of, another thing is like incentive alignment. So theoretically, first price auctions are not incentive aligned, so they don't necessarily provide the best value to the end users who are competing to each other. And if you want to build like an actual, like an auction that is both resistant against all of these privileges and like attacks and scenarios that the auctioneer can exploit, or like other people in the auction can exploit, you end up with like an encrypted auction, or basically a sealed price auction. But it's like a centralized version is not enough. There is also, it's not just because of decentralization as a value. If it's not decentralized, other people, like the auctioneer, can exploit their privilege. So if you want to build it in a like, the answer is like an Sealbit auction with a public broadcast, which is like a blockchain for us. And if you build it that way, you also solve a really important problem, which is like the last look problem of the block proposer. So simply when you have like the auction, running the auction, the block proposer can see the winning bid and they can like front run that. So for all of these reasons together, you can have like a better prices for end users, and you can protect your the market against like all of these like different kind of malicious strategies. And some of like a little bit like more about like where auctions are in DeFi are really important. There are some projects on the intent side that you really want to like make some auctions there. So a good example of that is like CoSwap. We've built something with them, and there is like, if you follow like in TradFi, like there was like Google's auction was actually a Sealbit auction when they had their own IPO. And you can have the same thing with ICOs in crypto as well. One of my favorite ones is like perpetuals. So there's liquidity auctions, and like there are some scenarios that if everything is public, people can like force liquid it because there is like some kind of information in the wild, and if you know that information, you can put some orders and like force liquidate some of the positions. So if it's like encrypted, you can prevent this kind of situations. And there is like pre-confirmations auctions, which is already Sealbit. So there is some projects like Premev who are running like centralized auctions, or like not that decentralized auctions. So you can use it for the same application. There is like MEV auctions, basically like Flashbots auction is like Sealbit today, but it's centralized. So if you want to build like a decentralized auction for MEVs, you can use it the same. Obviously, RWAs, like in many countries, they are selling houses with Sealbit auctions. NFTs, one of the cool things about NFTs is that like one of our projects with Stargaze is the reason that they are using Sealbit auction is not about like the fair market or just like cryptography or privacy. It just makes the whole process faster, because right now with the open auctions, they should delay the whole process with one block. But if you make it Sealbit, you can like conclude the whole auction in like 1 block, 2 block, not wait like for 10 blocks. So these are all my favorite examples, because like of course like privacy and cryptography is like has a lot of value for us, but there are also some kind of very direct monetary designs that having privacy and cryptography like saves you some money like in a very direct and immediate way, or like basically makes it like a better application for your users, and you can have like more users because you are more competent compared to other projects. And the other kind of things that I'm personally excited to build on Stylus is like, I call it like social fi, game fi, PvP markets, but any kind of application that there is like multiple parties involved and there's like a shared private estate and you want to combine them, can be a really good idea. There is like a lot of ideas. Poker, which is real time, is a good example. ask me like later if you want to learn more about that. There's also ideas about like prediction markets or like pari-mutual markets. In both cases, you need some kind of confidentiality. One interesting thing about, like, for example, Polymarket is that they are using UMA, and UMA is basically using like naive like hash commutable schemes. And if you really want to make it like decentralized, you can use something like this to make the whole like Oracle like somehow encrypted, but without relying on the like Oracle operators themselves. Yeah, obviously verifiable randomness generation is like something that is used in many like DeFi or like gaming projects. And one of my favorite things in general in games, like outside Web3, is there is always this kind of mystery boxes, and then you go to the next level, you unlock something, either for yourself or for the whole community. You can basically encrypt something, put it on-chain, and then like set some kind of conditions, and once those conditions are met, you can decrypt it for yourself or like some kind of community. So there are like, you can get really creative. We've built like some of these funny stuff. You never know, like some of these like funny examples in crypto get really big. And yeah, why Stylus? So Stylus is very interesting personally for me because like I'm coming from cryptography background, and most of the cryptography libraries are in Rust because of performance and security. And it's basically really hard to write like code, cryptography code in Solidity. So you can like, so the first reason is that if you want to write cryptographic code on a smart contract, you can use Stylus. And it's not like somewhere without any users. It's somewhere that people can actually develop and have access to like a good user base. And the other thing is like composability of like other tools that are available in the whole ecosystem. And yeah, one thing that turned out to be very interesting for us when we are selling it to other projects is like the permissionlessness. So whenever like all of these like cryptographic projects that we have, one of their challenges is that like you either like you should co-process everything somewhere else and just send the outputs to another chain, or you should update the whole chain like with precompiles or like modules and like all of the other like approaches. But with Stylus, it's like permissionless. You don't need to like install like a precompile for specific ideas. You can actually run it like decrypt at least on the smart contract side. And yeah, so I want you to, yeah, this is the QR code if you want to start building. Before everything, I want to show you like talk a little bit about the logic of the auction and how like we are going to build it, and like a little bit on the cryptography side. Basically, what we want to do is like we have like multiple parties and they want to encrypt their bits, right? Very simple. So you encrypt the bit, and all of the bits would be included in the blocks. So on the Arbitrum side, and once the deadline for the auction is reached, we simply fetch a key and decrypt everything and see who is the winner of the auction. But there is a catch. There is no centralized party controlling the key because we are running decentralized key generation. So with decentralized key generation, you can generate like a master public key and a master secret key in a way that nobody is actually holding the master secret key in one place. And like they can only reconstruct the key if like 2/3 of them are working together. So that's like the idea. And we specifically use identity-based encryption. The reason behind this choice is like it's very fast, like it takes like 5 milliseconds on the encryption side. It's not like ZK that takes like minutes on your side. And the amazing thing about identity-based encryption is that you only need to run the DKG algorithm only once, and then you can reuse the whole like secret shares and everything. And the better thing is that if you have like a batch of encrypted bits or like any kind of transactions, you don't need to have like secret sharing or like other kind of cryptographic heavy operations for each of the transactions. You can do that once for the whole batch. So for example, if you have like 100 bits and 100 validators, you don't need to generate 10,000 shares. You can only have like 100 shares. So the scalability makes it really practical. So I don't think we have time to actually like deploying everything, so I've just done it myself. And Yeah. Let me just show you the code really quickly. Okay, so the reason, if you follow the tutorial, the reason that we have like, I don't know, 5 contracts, cryptographic contracts, is that like we couldn't put everything inside the same contract. There's some limitations. So if when you see like cha-cha 20, like IB contract hashing, don't panic. It's just different like phases of our cryptography. And a little bit of explanation. Cha-cha 20 is a symmetric key encryption scheme, and IB is the identity-based encryption scheme that we are using. For optimization purposes, we are combining these 2 cryptographic schemes. We first encrypt the whole bit with the symmetric key, and then we encrypt the symmetric key with identity-based encryption. This way, the ciphertext doesn't grow like, I don't know, really big. It's just like limited and more optimized. Don't panic. It's a very simple technique called hybrid encryption if you want to search. And basically, yeah, let me just run the code so it would be more exciting. Yeah, I didn't know anything about this. Like, I didn't write the code. My co-founder, he got sick. And I started running this like 40 minutes ago myself. So it's actually possible to build it in an hour. So that's a good thing. Sorry, say again? Okay, sure. Yeah. So yeah, I already like deployed the contracts and everything, and I'm just like running it to show, like give you what's happening here. Like I just put like 2 bits, like 100 bit and 150, and then once the deadline of the auction is reached, it automatically fetches the decryption key from our committee, and yeah, decrypts it and see who is the winner. So one of the interesting things here is that you don't actually need crazy cryptography. You don't need to prove like your bits are like, I don't know, like correct with ZK and then compute over them with like FHE and all of the stuff that takes like minutes. Here we simply use like some kind of cryptography that is really fast on the user side, but since it's only pre-execution privacy, we can compute like at like maximum level of efficiency after decryption. So this is like one of the things that I call like dynamic cryptography, because yeah, the last step of art is simplicity. Thank you.
Any question from, yeah, awesome.
Yeah, thanks for the talk. I have a quick question about the identity-based encryption part. So I'm not familiar with this at all, but I read somewhere that there's some kind of like centralized party involved in those kind of schemes. Mm-hmm. How do you mitigate this? Are you using DKG for this to make it decentralized? Yes. And then the IBE part, how is this implemented? Like, what are you using this for exactly in this case?
For sure. Yeah, so IB, like if you search on Wikipedia, it says that it's like centralized, but if you use DKG, like any other kind of MPC algorithms, it would be like completely decentralized. And you can actually make it secure with like more fancy like cryptographies like tracing algorithms, or I don't know, like TEs for like corruption risk that normally people talk about it if you're interested. Yeah, so like in general, we just use DKG. And the good thing about IB is that we just run it once. You don't need to run it every single block. And regarding your second question, we are using Bonner Franklin IB. And yeah, it's just like enough. Thank you. Any other questions?
Sorry, just to follow up, is the code open source, or is there like a white paper or something on this,
yeah,
especially
so there
the
is
IB
my
part?
paper and thesis. There's like explains the IB part. If you go to our it's just like for 3 years ago, but it has all of the details. It's mostly about MEV prevention, but the same flow holds. And if you go on our website, fairblock.network, there's like more details about like all kind of applications that you can build. Obviously our Discord and like Twitter, if you can send us a message, like we would love to help you to build like any application. And in the same QR code, maybe I can just show it quickly again. Yeah, we have really, really good documentations, at least for the Stylus example. If you want to build, like, it just takes, like, I don't know, maximum 1 hour to run it, and then you can just change it to your own kind of application. And yeah, obviously, if there is anyone interested to build, like, perpetual markets, options, or any kind of DeFi markets, ping me. I would love to help. Thank you.